Hello everyone. There is one other important theorem about tangents that is going to help us out. So we already talked about the theorem that tangents are perpendicular to a radius of a circle. So for example, just to review that in this picture here, if I were to draw the radius from L to H, that radius would be perpendicular to this segment JH. So that's one important theorem. The other important theorem is that if we have two tangents that share a common external point, those tangents have to have the same length. So if I look at this example and we take a look at the information that's given to us, it says JH is tangent at point H. So this segment touches a circle in exactly one spot here at H. And it tells us that JK is tangent at K. Okay, so that segment touches at exactly one spot here. Since they're both tangents and they share this common external point of J, these two segments have to have the same length. Okay, so with that theorem, it gives us a nice way to be able to set up an equation to figure out some missing information. So in this case, because those two segments have to be the same, JH has to equal JK, which means that 7x minus 23 has to be equal to 61. So it gives us this tool as a way that we can set up this equation. And then we can finish solving to find for x. So adding 23 to both sides. So we get 7x is equal to 84. And then to finish, divide both sides by 7. So x is 12. So it would mean if we plug 12 in for x here, 7 times 12 minus the 23, we should end up with 61. Okay, this theorem also works the other way as well. This is another biconditional statement. So if I have two segments on the outside that touch my circle in one spot, if they have the same length, then they're both tangents. Or the way that we use it here, I know that they are tangents, so therefore I know that they have to have the same length.